Next property for alkanes is solubility. Solubility of alkanes decreases as the number of carbon increases. So if we have methane, ethane, propane, so methane is more soluble, propane is least soluble. More is number of carbon atoms, less is solubility of alkanes, right? So alkanes are relatively more soluble in organic solvents and less soluble in polar solvents such as water. More solubility in covalent solvents such as benzene, carbon tetrachloride, carbon disulfide, ether. They are non-polar solvents and alkanes are more soluble in them because alkanes are also non-polar, because there is a concept in chemistry that says like dissolves like. Like dissolves like. So non-polar solutes dissolve in non-polar solvents and polar solutes dissolve in polar solvents. Alkanes are non-polar, so they dissolve in non-polar solvents such as benzene and CCl4, and they are less soluble in polar solvents such as water. And as number of carbon increases, then non-polar character increases. So solubility in water decreases. Alright. Next we have another property called melting point. So melting point is more for a symmetrical molecule and melting point is less for unsymmetrical molecule. So there is not a regular pattern throughout alkanes, but in initial members we have observed that even number of carbon containing alkanes are having higher boiling point than odd number of alkanes, but that does not go for lot of alkenes. That is not a regular trend. So in general the concept is more is the symmetry, more will be melting point. Alright, it is not like as in boiling point we used to say more is number of carbon, more is boiling point. In melting point we have to see symmetry is there, melting point is more. No symmetry, melting point is less, and solubility and carbon is inversely related. Next is chemical reaction. Chemical reactions which we have in the alkanes are basically substitution reactions, oxidation reactions, isomerization and aromatization along with polymerization. Substitution reactions happen during halogenation, nitration, sulfonation, and under oxidation category we have complete oxidation where hydrocarbon is completely oxidized to carbon dioxide and water, where a hydrocarbon having carbon and hydrogen, carbon will go to CO2 and hydrogen from hydrocarbon will form water, that is complete oxidation. Whereas incomplete oxidation give us carbon black and steam or water, and controlled oxidation occurs in the presence of different catalysts which can form alcohols, aldehydes or carboxylic acid depending on which reagent you have taken. Substitution is a simple reaction where one group will come and some group will go away, such as in alkanes halogenation is a substitution reaction where what happens is from alkane H is removed and halogen comes in. Hydrogen goes out, halogen comes in, and the reaction is substitution and it occurs in the presence of sunlight. So it is a free radical substitution reaction. Halogenation of alkane is free radical substitution reaction. So that's it.